Hi there, folks. Here we're looking at scientific notation and how we can apply rules of exponents to scientific notation, okay? This is one of the best applications for our rules of exponents is applying it to scientific notation. It's a thing that you'll do a lot in science class and that kind of stuff. And so the first thing here is let's remind ourselves what scientific notation is. So scientific notation is in this format, a times 10 to the b power. It's always some number times 10 to a power. And you just have to remember that this number out front here, remember, has to be between 1 and 10, okay? So between 1 and 10. And keep in mind, you're allowed to equal the 1, so we can be equal to this guy, but we have to be less than the 10, okay? We can't break into those 2-digit numbers, all right? So when we look at that number out front, it's got to have at least a single-digit value. It can have decimals that trail behind it, but it can't be a 0 there. It can't be a decimal of 0 point something. It has to be at least 1 point something. And it can't exceed 9.9999, okay? It's got to be below that 10. I can't have a double-digit number in front of the decimal, okay? The b value up here can be positive or negative. All right, and really we use positive versus negative to express the type of number we want. We use positive numbers to express really, really large numbers for these, and we use negative numbers to express decimals. Because when we think about our rules of exponents, a negative number means division, and we divide to get those decimals, okay? And so really, scientific notation is an abbreviation. It's a way to kind of abbreviate really big or really small numbers without having to write all the zeros that get tacked onto these things, okay? For example, if I look at something like this guy, this is a really large number, so I can rewrite it as scientific notation, and I can use a positive exponent for my value of 10 in order to express that really large number, all right? And so I think about placing the decimal on this thing. That's the first thing I need to start with. You know, when I talk about scientific notation, I have to have decimal values with a single digit in front of the decimal, all right? And so I think about where the decimal is right now. Well, the decimal right now is at the end of this thing right here. That's where the decimal always is when we don't have it written. And I want to place it so that I have a single value followed by decimals. In other words, I need to place that decimal point right here between the 5 and the 6, all right? And then it's just a matter of counting how many spaces that is. So I just count 1, 2, 3, 4, 5, 6, 7 spaces. And so what I do is I rewrite this thing as 5.61, and then I say it's times 10 to the 7th power because I want to move that decimal 7 places, okay? That's how I express this really, really big number in scientific notation, all right? I do the same thing when I'm going the other way, except I use a negative number to express really small decimals, all right? So once again, I need to determine where I'm going to place this thing. And when you look at this, to get a single digit followed by decimal, I need to put the decimal point between the 4 and the 2 right here. And so if I place it between the 4 and the 2 as a 4.2, and then it's just a matter of counting how many spaces I moved the decimal. The decimal's right here. I moved it 1, 2, 3, 4, 5 spaces. And because it was in the negative direction, I moved it 5 spaces in the negative direction. So I do times 10 to the negative 5th, okay? Because that's what negative exponents do. They divide, they make the number smaller, okay? Our application is going to be a little bit more complicated. A lot of times when we're doing rules of exponents, we're going to end up kind of breaking this thing out of scientific notation. And so when I look at this one, this isn't scientific notation because the decimal isn't quite in the right place. So if I want to adjust this to scientific notation, I need to move this decimal one more spot to between the 7 and the 3, making it a 7.35. But then that changes the exponent here by one more value because I moved it one more space. This is going to be times 10 to the 26th power, okay? And if you're ever unsure about which way to change that exponent, just think about what this thing would be in standard form. Like right now, if I move the decimal 25 places, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way to 25. Now thinking about moving it back to where I was. Like if I started back here and moved it 25 spaces to here, I'd have to move it 26 spaces to get between the 7 and the 3, okay? You can also just memorize, like, depending on which way I move it, I add or subtract from that value, okay? If I look at the next one, same kind of thing, but notice I changed this a little bit. If I moved it 25 spaces this way, well, moving it 25 spaces back would bring me to here. Well, I actually want to move it 24 spaces to get in between the 7 and the 3 this time. So I want to rewrite this as 7.35 times 10 to the negative 24th instead. Okay. And so again, it's a matter of thinking about where would the decimal be when I actually wrote out the standard form number. How do I move it back to the correct location? Okay. Or thinking about it adding versus subtracting. All right. This one, same kind of thing. I have to move this guy to here instead. So I'm going to do 5.7. And it's almost like this one was 2 spaces too many. I had to move it back 2 spaces. So I'm going to change this to a 10 for my exponent, okay? And again, that becomes really important when we apply rules of exponents, because sometimes we'll get answers that look like that, all right? This one, same kind of thing. This should be a 5.7. But when I was moving in the negative direction, it's like I had to move 2 more in the negative direction. So I'm going to make this times 10 to the negative 14th in order to put it in proper scientific notation, okay? So now applying rules of exponents. To apply rules of exponents to scientific notation, I simply use the a value as the coefficients, and then I apply the rules of exponents to the powers of 10. So those powers of 10 will act as my variables in this situation, okay? So the a values are my coefficients. I apply the regular operation the same way I always would, but the powers of 10, I apply rules of exponents. So when I'm multiplying, I add the exponents. When I'm dividing, I subtract the exponents. When I'm raising to a power, I multiply the exponents, okay? For example, when I look at this guy, again, the 2 and the 4 I treat as my coefficients, so I apply regular operations of multiplication. 2 times 4 is an 8. And now I apply order rules of exponents to these values of 10, to these powers of 10. So I do 10 to the, well, when I multiply, I add the exponents. So it's 10 to the 15th. And that's it, done. Okay. The tricky part about this, if I look at the next one, is I still apply this the same way. Like, these are my coefficients. So 5 times 6 is a 30. I use rules of exponents for the powers of 10, so that's going to be 10 to the 19th. But now I'm in a situation where I no longer have scientific notation. This number got too big, so I have to adjust it a little bit. I need to put this as 3.0. I need to move that decimal. And because I moved it one more space, I have to change this to a 10 to the 20th, okay? And that's where this becomes a little bit tricky, all right? As I perform operations, I might get much bigger or much smaller values, and I need to adjust it back to scientific notation. Okay, if I look at this one, 3.6 divided by 1.2, I do the division the same way I always would. That gives me a 3. And now for the tens, I apply the rules of exponents. I'm going to subtract the exponent, which is 10 to the negative 13th. Okay, and that's done. It's still in scientific notation, so it looks good. If I look at the next one, again, and you can use a calculator for this, but you take the 3.75, you divide it by the 7.5, because again, we treat those like the coefficients. We just divide those the same way we always would. If you divide it on a calculator, you get a 0.5. And now apply rules of exponents to the tens. I subtract those exponents. Negative 4 minus 6 is a negative 10. But now what happened is the number got so much smaller that it popped out of scientific notation. I need to move this decimal back to here. And because I moved it in the negative direction, one more space in the negative direction, this is going to become times 10 to the negative, 11th. I wrote the 10 again, okay? So we do need to adjust this to make sure our answer is still in scientific notation, okay? And then once again, raising things to a power, 1.5 to the fifth power. Once again, just do that on your calculator. It's a regular old number, raising to the fifth power. That's a 7.59375. I just did that on my calculator. But now I apply rules of exponents to the 10, so I multiply the exponents. That's a negative 35. Okay, and that's it. If I look at the next one, 5 to the third power is 125. You can do that on a calculator. But now I apply rules of exponents to the 10, and I do it as 10 to the 36. I multiply those exponents, okay? And now I need to make some quick adjustments. I need to move this 2 more spots, so I'm going to rewrite it as 1.25. Because I moved it 2 more spots in the positive direction, I'm going to make this exponent a 38, okay? So again, we apply regular old operations to that number that's out front. We treat that like the coefficient, but I apply rules of exponents to the 10. and then just make sure you adjust your answer to keep it in scientific notation. Okay?